All right, so we've got a couple things to look at today for this session. I think what we'll start with is just actually to look at some of Stan Brackage's work, and actually I've got a little tool that I've been making for the past couple of months that I've never shared with anyone. So y'all get to be the first ones to play with it, which means it needs lots of additional features and things. So you're more than welcome to tell me what else to make on it, and we can build it out and make some cool stuff with it. So we'll start there. One thing I do want to share actually before I do that is um, I meant to record a tutorial this week on how to use this new machine learning model. I did not get to it yet because of illnesses, um, but there is, hold on, let me see if I shared with video and audio. Okay, share sound. All right, so there's an interesting new tool out called Spec VQGAN. Let me see if I can find this real quick. Spec VQGAN. Here it is. I'll post this link in the chat. And the idea behind it is kind of similar to what we were talking about with Soundtrack, which is what you can do is you can feed this model an image and it returns a sound to you. Man, where is my chat here? Here we go. Chat, chat, chat. Okay, cool. So the way this model works is you can feed it actually a short video. And when you feed it a video, it sort of determines what category the video is from, and then it feeds you back a sound. So this might be a fun tool to play with, almost in that sort of soundtrack world where you feed something an image and it spits back a sound. And I guess in many ways they're sort of correlated one to one. Here is a quick demo of what I did. Obviously, if you feed it abstract stuff, it is very confused. And it produces very fun, glitchy noises. So before I start, this is a very flickery video and is very noisy. So if either of those bother you, mute and avert your eyes. But yeah, let's play. Yeah, so that is this thing called SpecVQGAN. Like I said, I'll record a demo if anyone wants to play with it. Obviously, if you feed it abstract images like this, it has no idea what to do and it produces lots of fun noise. If you do feed it like a video of someone playing drums, it actually produces like Congo drums in return. It's kind of cool. It doesn't really work particularly well. I was chatting with some friends. We might try to train our own version. Like one thing you think about is like, what if instead of trying to do it with like real images, like photographic images. What if you instead trained it to see like if it saw a triangle, it would produce like a saw wave, or if it saw like a circle, you could produce some other sound. So there's probably ways to do some fun stuff with this, and maybe in the future we could look at something like that. But this came out this week, so I just got a quick chance to play with it, and I'll share a notebook if anyone wants to mess with it to do it themselves. But yeah, here again, like we're slowly getting to a place where you can start to like envision ways to like produce sound from image and image from sound, right? This could just easily probably work in reverse, where, well, I don't know how easily it could be produced, but essentially you could do like an image, or sorry, you could do a sound wave, like a spectrum of a sound, like an audio spectrum analysis, and that could be paired with images, and you could produce images from that. So actually, I'll have to find the project. A student of Tom White's, I don't know if anyone knows Tom White. His name is Dribnet on Twitter. A student of his a couple years ago did a pix to pix model. We haven't really covered pix to pix in this class, but essentially it's image pairs that I'm waving my hands like you can see me. It's image pairs. You can pair up images, and then it can produce new images from the pairs. So in that class, what that student did is they took an image of a bird, and the sound that that particular bird makes, and took the like spectrum analysis from that sound and paired them together. And then what you could do is you could feed it a new bird that it never seen before, or some other animal, and it would try to reproduce a bird's spectrum sound from it. So there's lots of tools and techniques to do this sort of stuff, and I think there's more opportunities for this, and especially in machine learning, essentially what you're doing is you're sort of saying these things correlate, even if there's no way they actually do correlate, but the machine learning model learns to figure it out or like tries to figure it out, and then you can do fun stuff with it. So lots of opportunities in this space, and I think people are starting to get more and more into it and trying to figure it out. But for now, there's a cool model to play with. So I should also say, like, what we're going to look at today is actually more of this. So this particular video that I made is all crops from a book that I scanned, right? So I scanned a book, I pulled out all the images, and then I sequenced them using the tools we're going to look at today. And then we can also do some of the brackagey stuff, right? So we can start to play with how frequently the images repeat, and do we pause on a certain scene, or can we pause in other places? But yes, I will definitely find a link to that bird spectrogram. I probably have to dig it up from Tom's. Tom probably DM'd it to me, so I'll have to find it. But I will definitely share that with anyone that's interested. What I think is really interesting, again, this will be, she'll say this whole class will be maybe flickery images depending on what your image is. So if that does affect you, let me know, or maybe just like hang out for a little bit and try to avoid watching the video. But I've made this video series what I've started to describe as like responsive structuralist films. And the idea here is that if you take the same data set and you crop images at different scales, you actually get different speeds of the change, and you get different lengths of film. And it's sort of really interesting because, I don't know, it's just sort of really interesting. So this is, again, this isn't machine learning, right? Because we're not really doing anything with deep learning. But it sort of correlates with machine learning in the sense of like having to build a massive data set. And then what do you do with it? So if you've ever seen any of Brackage's work, all of his stuff is hand painted. And he paints every cell individually, almost like he's animating it, hand animating it. And I'm sort of like, I'm the lazy man of that, of like, I will find other things to scan and crop and take that, so I don't have to do all that hand painting myself. Another fun TMZ fact, or maybe not fun, it's actually rather dark. The inks that Brackage painted with, he believes are what gave him cancer and what eventually killed him. So yeah, by just scanning in other people's work, we will maybe not meet the same fate. Sorry, that's kind of dark. But I think there's just some interesting things to play with here. And I should say, like, if I just hit exit, you can actually see how this works. And this is what we're going to look at today. So we'll basically take an image and we'll break it up into frames by doing a what we call a window crop, and then we'll play with them in sort of creating rhythms and that sort of thing with it. But you can sort of see here, like, this is the same image, right? Imagine that this image is much, much larger. But you can see the corner is this upper left-hand corner is the exact same, and all we're doing is taking a wider and smaller crop of these things, and it generates really interesting patterns. And especially in this one, I've shared this one on the internet, and I'll probably share it again. But this one, because of these smaller windows, there's moments where it creates a rhythm where things are definitely moving, like your brain connects the dots and makes it move in really fascinating ways. So again, sort of some of those Gestalt principles about like how our brain makes things make sense even though they might not, kind of come into play here. So that's what we're going to look at today. So again, I should say this might be kind of a flickery class, so if that is a thing that bothers you, definitely like take care of yourself first. All this stuff is just to show like examples of things, not like you're forced to watch these and make yourself sick, so please don't. All right, cool. So let me share this notebook with everybody, and we will go through this. Come on. Okay, let's refresh the page and see what's going on here. Okay, let me give you this notebook in a different way. Okay, so open up this link, and once it's open, you can just hit this open in Colab button here, and it should open directly in Colab for you. Let me know if that doesn't work for anyone. Everyone got it? All right, cool. So there's two parts to this sort of material what we're going to do. So the first thing is we need to make our frames. So we'll look at a way to basically take a big image and crop it into smaller pieces, which is actually a fairly common technique for experimental filmmakers. What do we see? So Beyond Delcaire is actually made in kind of a technically similar process. Hold on, I'm going to turn my camera here again so I can use my hands. So imagine that you have a long film strip, right? And that film strip has frames on it, right? There's little square films on it. The frame itself runs horizontally, but the film runs vertically. So in order to make some of those dancing line techniques, what those artists do is they draw a line that's slightly at an angle across the entire strip of the film, and when it plays back, each frame like moves the line a little bit to the left and to the right. And again, our brain connects the dots. So this has been a technique that people have used for a century now. Len Lai was one of the early artists to use it. I'm sure people before him were doing similar techniques. So this is not a new technique. It's just maybe sort of made, instead of drawing our thing on leader film and then running it through a film projector, we're just cropping images. So we're going to follow along with that. So we'll do that. And then once we have our frames, we'll be able to sort of play with them using rhythm and time and that sort of thing. All right, so the first thing we are going to do here is we're going to run this first cell, which is just our setup cell. The other nice thing about this is that we don't need a GPU. This is all Python. You could actually do this locally, but because I don't want everyone to have to install Anaconda and go through that rigmarole, we're just going to do it here in Colab. If you do want to install stuff locally on your local Mac or whatever, let me know, and there's a link to a video on how to set it up here. So go ahead and run both of these. While this is running, let's go ahead and upload an image. So just come here and click on the folder, and we will upload an image. So I'm going to go here, go downloads. I believe this is the image I want to upload. So I'm just going to upload mine's going to be pretty large. Yours can be a little bit smaller. I think this is something like 4,000 by 6,000 pixels. Just a scan of a book. And then while I'm here, I'm also going to upload a video. I wanted to upload this video. So this is a little video of someone dancing. So go ahead and upload that as well. So if you only have an image or only have a video, feel free to just upload whatever you got. All right, so while that image uploads, so what do we do with this cell? So in this cell, we downloaded two libraries. One is called Dataset Tools, which is a tool that I've made. Many of you who have taken my other machine learning classes know about this tool because it helps us produce datasets. But in this class, we're actually just going to use it to produce a bunch of images. And then we also installed another tool that this is the one I've sort of been working on off and on for and I mostly mean off. I've been working on it a little bit for a couple months now. It is very bare bones, but we'll play with it and we'll maybe think about how to add some new features to it. So the first part of this process is to use the Dataset Tools library, and we're going to use this script called window. So let's take a look at what's available in it. So if we run this cell with the -h, what this will give us is all of the other options to run with it. So you'll see here, if you're familiar with Dataset Tools, you probably know what a lot of this looks like. We have an input folder, so we need to point that either at an image or at a folder of images. And then we have an output. This is where we're going to save our images. I'll skip over offsets for now. We need to set a height and width. So this is the idea of how big should our window be. So the reason this is called window is because in machine learning, there's a concept of a sliding window. So what we're doing is we're sliding a window across an image and taking a chunk of it every time we slide it across. So we need to set what the height and width of that window are. And then we need to set a direction. So again, if you think about a big rectangle and we're sliding a little rectangle over it, do we want to go left to right and then top to bottom? Do we want to go top to bottom and then we get to the bottom, we want to go left to right? So we have to set a direction. By default, this will always, I believe it defaults to across. It's like reading. So it goes across, down to the next row, across, down to the next row, across. If you want to flip that, you can do that using direction. And then there's a couple other things about here about whether we want to keep the name of the file or whether we want to number it. For this, we'll number it because it's a little bit easier for us to produce video out of FFmpeg with that. So this line down here is pretty much all we need to do to run a really simple version of this. So make sure that your file is here after -i. -i stands for input. So make sure you copy the path of your file and put that here. And then this is the folder where we are going to save all of our images to. You're welcome to rename this whatever you want, but since I know I'm going to be doing a 640 by 480 crop, I just named it 480p, just so I sort of know the dimensions of this thing. And then we need to set a height, -ht, and then a width. Also, I should say, like, the order of all of these don't matter. You could put this at the end. You could put it at the beginning, as long as you have the dash and the like sort of answer. So this is like sort of the question and the answer together. You can sort of reorder things. So don't worry. Like if you prefer to put width in front of height, whatever, do your thing. And then lastly, what we want to say is we want to save these as numbered. So this one, technically, I believe it actually is this. It's numbered equals true, but you can just pass in -- numbered, and that will just produce a number of images. So as long as you've got this set up, you're pretty much ready to go. So we'll go ahead and run the cell. And if I refresh my folder window, you'll see 480p. And in here, I have what looks to be about 100 images. You might have less because of the dimensions of your image. It doesn't really matter. As long as you got like more than 10, we can at least produce a video that you can sort of see and scrub through. So as long as you got some images out of there, you're ready to go. Here is our ever magic or ever annoying ffmpeg command to convert a bunch of images into video. So we will just run this. So as long as you named this folder, kept it 480p, you don't need to edit anything here. If you change the folder name, just make sure you change this to be whatever your folder is. And then I just always use the same name as my folder just so I know where things are. So you can save the name. Everything in between here, you don't really need to worry about, this stuff especially. One thing that you might want to play with a little bit is the -r. -r stands for frame rate. So that is how many frames per second do we show. It's kind of like a weird film thing that most people use 24. We'll talk about why 24 is really helpful when we get to rhythms. But 24 tends to be a common one. If you find that's too fast for you, 16 is also another common one. You know, most film today, like mainstream film, was shot at 60, which is going to be very, very fast. I don't recommend that for this particular process. Maybe if you're doing other things with it, it'd be fine. But for this, I recommend just maybe leaving it at 24. So go ahead and run the cell. And that produces our little video here. I already downloaded it, so we can just go ahead and watch it here. So again, this will be rather flickery. So there we go, bootleg brackage. Now, I actually recommend that you, like, depending on your image or depending on what you're just playing with, I recommend playing with your settings of this Windows script. One thing that's kind of fun to do is play with the height and width. So maybe you want to do something for Instagram and you want some more vertical video. You could use a height of, you can actually flip these around. You could do a height of 1280 and a width of 720. I don't think that's the actual dimensions of what goes up to Instagram, but it's close enough. This is what, is this still 4:3? I can't do math today. It might be closer to 16:9. I can never remember. But you can play with this. And the thing to know is that the bigger your window is here, more or less the faster your animation is going to feel. So maybe we could make this even smaller. Let's try 480 by 360. And I think what would happen here is it would feel a lot, would feel slower. And you can also play with direction. So maybe your animation, you want to go down, and then back to the top, down, back to the top, down. Laura, you only got one image. Do you know how big your image is that you uploaded?
Sorry.
No, that's fine.
It's I don't know how many pixels, but it's 560 kilobytes. Is that too small?
It might
Probably.
be. If you just, are you on a Mac?
Yeah.
Okay, if you just click on your image and just open in preview
Uh-huh.
and then go This will take a second to open on mine because it's so big. If you hit Command I and the inspector pops up, it should give you the image size.
Oh, okay, yeah, it's only 1200
Yeah,
pixels.
so that might be why you got only one image. Your other option would be to make your window a little bit smaller here and just sort of like see what you can get from a smaller image. Yeah, that's kind of the challenge with this work and why I tend to have really, really high res scans for this stuff. Yeah, so try that and see if that changes anything. So I'm just gonna run
Okay.
this one really quickly and see what we get with us with a smaller window. For those of you who have not played with any of the AI tools, there's a really cool image upscaler called Gigapixel AI you could run this through to upscale all the images to be bigger. So if you're like, I don't want to actually produce a 360 by 480 film that's so tiny, you can run it through an image upscaler to get a little bit of a higher resolution for it. So let's just try 360. So I don't know how much slower that really feels, but you'll definitely notice if you find a couple high-res images and you play with the scale of them, you'll definitely feel that like some things move in different ways. This works especially nicely with patterns. So if you find like image pattern, maybe like you go onto a stock website and just download some free like pattern backgrounds or things, you might get some interesting results with that. You might also get interesting results with a gradient because of how it skips. You might get like some interesting plays where it feels really smooth and then it jumps to a different color. So there's lots. This is honestly a tool that like I just sit around with and play with at night just to sort of see what I can produce. It's probably like the dumbest and cheapest way to make a video I can imagine, but it's kind of fun. The other thing I should note is that right now we're just pointing this at a single image. You can also point it to a folder of images. So the example that I showed of that whole pattern book is actually just a folder of images. So it just goes through all of them and processes them all at once. So that's nice if you want to make something a little bit longer, play with those a little bit more. Okay, so now we've made some frames. So we've got at least a handful of frames here to work with. Yeah, it is instant gratification of being the laziest person on earth and producing lots of video out of it. But it's fun, and it gives me a reason to scan all these books and sit around and scan for days. So one other thing is, this is another piece of code that you've probably seen before, but if you did upload a video, you can run this code to produce still frames from your video. So I'm going to run this, and it's going to take my little dancing guy in a polka dot shirt and convert these to individual frames. So Kaiman, my guess is that if you got an error about the end of your JPEG, either your JPEG hasn't finished uploading completely, or the JPEG itself might be corrupted. So sometimes what you can do is, even if it opens in Photoshop, there still might be an issue with it. So if you can open it in Photoshop, you might just want to resave it out, and that should work. Okay, so now we also have a folder of video stills. And so now we can begin to stitch these back together. So we're going to use this tool called Vidim. It's mostly video rhythms because I like dancehall music. So there's two things you need to think about in terms of how this tool works. So one is the actual. It's sort of built around. Do you ever use like Fruity Loops or Acid as a music tool, where like you had a bunch of loops and you could like stack them and play with them? It's sort of that conceptually for making images or providing image rhythms. So the first thing is we're going to move into that folder just to run the script from there. And then let's take a look at the help command just to sort of see what we got. So in the help command, there's a thing called frame rate. So we know we want to set a frame rate for this. Again, it defaults to 24. I'll talk about that in a second. Next, we want to point it to our folder of images. And then there will be an output. And then there are two other things here that we have not talked about yet, which is called playlist and then rhythms. So again, the idea here is rhythms are sort of like the smaller loops or like the smaller little bits of how you might structure a rhythm. And then a playlist is sort of how you combine those. So you can almost think about like take your drum loop and then add in a guitar loop afterward, or like maybe you've got one drum loop that is, just a really basic, 1 2 1 2, and then you've got another drum loop that's more like, you know, I don't know, doing like hi-hats or something. So that's sort of conceptually how this works. So we can take a look at how this then works. So this might be something you haven't seen in Colab before. You can actually write a file to your system directly from Colab by using this fancy little thing called write or percentage sign write file, and then how you want to write the file. So what we're going to do is we're going to load in some content or some ideas. We're going to run that through the script, but it's nice that I can edit it directly here in Colab. So if any of you have seen me fuss around with like going into one of these files, double clicking it and trying to edit here, you can do that. That's how this worked up until this morning. And I've changed it so that it's a little bit easier to edit directly in Colab. So what we're going to do is we'll create a rhythms file, and then we'll create a playlist file. So let me talk a little bit how the rhythms file itself works. So remember that we're working in 24 frames per second now. We can change that, but for now we'll just stick with it because it's a little bit easier to understand. So let's say I want a image to be on the screen for 1 second. So the way to have one image on screen for a whole second is to use that image 24 times in a 24 frames per second loop, right? So that's essentially what this says. This creates a whole bunch of patterns that then tell me how often to repeat that image. So this is my naming convention. I would definitely recommend that you name your stuff however you want. So hold 3 stands for hold for 3 seconds. Hold 2 is hold for 2 seconds, and then hold is 1 second. So remember, these are frames. So I haven't really gone to a place of where like you could provide these as seconds, and I could take the frames and sort of guess from there. Maybe that'll be a future iteration of this. But essentially, the idea here is that you're just giving a number of patterns, right? So the reason that working with 24 frames per second is really helpful is it tends to be divisible by a lot of stuff. So one of the things is that it's obviously divisible by 1. So there's this thing called 124. So what it's going to do is it's going to loop through all the files in my folder, and it's going to play each one of them at 1 frame per second. So if there's 24 frames, this will be a 1 second animation, and each frame will play for 1 frame. Next, there's a thing called second hold end, which just does 24 frames, and then the very last frame it holds for 24 seconds. There's also something like if you want to break something into sixths, it turns out 6 breaks into 24 very easily. That would be 4, 4, 4, 4, 6 times. And if you want to do something like a quarter note, right? This assumes that I guess you're working at, what would it be? I don't know what that would even calculate to in beats per second or beats per minute. But this is sort of saying like break a second into 4 chunks, and that equals 6. So you could also think about like what's a half, like maybe a half hold would be something like hold half, and that would be 12 frames. Okay, so the key here is you're defining all of these names and then how long it works, how long it lasts for. So that's rhythm. So once you've got these set up in here, what you can do is you can just put shift return in this cell, and that's going to create a file called rhythms.txt. And if you refresh this, oh, did anyone else lose my audio? No, okay. Steve, I don't know. Maybe it'll come back. So now we've got a file here called rhythms.txt, and if you double click on this file, you'll see it has all of the things we just defined. The way this works is that every new construction must be on a new line. But if you get sloppy, like you forget to do this or something, I think it'll still work. I debugged a fair amount of that, but it might. I would say like try to be somewhat careful with how you construct these, or it might break. If it breaks, just send me a message and I can try to fix it, or like work in another system to make sure it gets cleaned up. So this is just defining all of our functions, or like all of our little rhythms. Okay, cool. Thanks, Steve. Good to hear. So next is we want to write a playlist. So a playlist is literally like, how do I structure these little elements, right? So in this case, let's say I want to hold for a second, and then do a bunch of these really fast movements, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 1 per second. So this just defines the order in which this operates. Oh, great. Thanks, Sean. So this is a way to just sort of build up a playlist. So all this says is like, take these patterns and just duplicate them in this order. So sometimes it's easier just to like play with to do this and just watch and see what happens. So let's go ahead and save this one out as a playlist. So again, we'll click on the cell and we'll just hit Shift Return. And now we have a playlist. And if you double click in here, you'll see it should just be this. Here again, I did some stuff where it should just work fine. Like if you do this, I believe it'll still work. What I've found is helpful is sometimes when I'm doing a really long video, I'll break these into little segments just so I know what I'm working with. Like, you know, and I might even add a comment here, although comments probably don't work. Well, we can work on that. But basically you could structure this however you want and it should probably like still work fairly well. Again, if you get error messages, let me know, I'll fix it. But you know, for now we can just work out this. So what is this gonna do? It's gonna be hold for a second, and then do two, like 1 frame per second, and then do 2 quarter notes. So this should be 1, 2, 3, 4, 5, 6. This should be a 6-second film, essentially. So now we've saved this, we can go ahead down here. This is the script that's going to run it. So again, our input is the folder of images that we are providing it. And the out is where we're going to save it. So -O is where we're going to save it. So this will make a new folder and save it out. And then we want to point it toward our playlist and point it toward our rhythms. So let's go ahead and just run this cell. And one note is because I assume you want to make a video out of this tool, at the very end it will produce the video for you, so we don't have to use that little FFmpeg code. So if I come over here and hit refresh, I'll see 480 out, and in here I'll have a folder called frames and then a file called rhythm. I should really work on automating the name of this thing because now I have like 30 rhythm files on my desktop, but it works. So if you come in here and just open, and you hit play, hold, really fast, less fast. So really simple way to produce rhythms. You could, Nowco will tell me you can probably produce this in After Effects very easily as well. And I'm sure you can, but it's like kind of fun just to play with this almost again, just automating. Like, again, you could also tie this to other things, right? There's no reason to say, in this version, it kind of, you're required to sort of provide these with as a thing, but we could also tie this to something else, right? We could say, what if it's the weather or the, I don't know, a clock timer or something, and we could say like, you know, if the weather is above 70 degrees at this minute, do this. If it's at this minute, do this, right? We could tie these data sets to also produce something that is like rhythmically attached to another thing. Kind of well, the fun part about this is you can start to tie these things together. You know, maybe here again, we want to do something where it's like, I know Diego's been really interested in creating video using maybe his body. We could do something like our pose detection, and we could track a pose detection and say like, okay, if you see my hand up here, do a hold. If you see my hand down here, do a 124, right? And we could begin to like, you probably couldn't do this real time, but you could begin to sync these things with data to begin to play with stuff. So I think there's a lot of, again, this might be like kind of a weird angle to come at visual music from, but I think we can also see how this builds up over time across other tools. So the last thing I want to show here is an example of how this could work if you wanted to do this with the video file. So again, I've set up a playlist here, and in this playlist, I have a much longer set of instructions. It basically just still uses this pattern. One of the nice things is that you could fill this up with a bunch of patterns and then just reuse them as much as you want, right? So instead of trying to like literally write out every one of these, you can sort of begin to construct your own rhythms and own setup of things in kind of a nice sort of like Lego block kind of way. So if I save this one out, it's actually going to replace my previous file. So this will just overwrite the file that already existed there. And then this one, I'm going to comment out the Diego special for now. This will just take, this looks at my video file, and then we'll produce a new video from that. So we'll go ahead and run this. And I clearly have some debugging stuff in here, so I'll clean that up. And by the next time you run this tomorrow, it'll probably be gone. So let's take a look at what this file is. So video out, and then rhythms. Here we go. Download this one. And what you have here. So what's kind of interesting is I'm not sure the frame rate of this video when I originally pulled it. It actually looks like it's maybe 30 frames per second because he seems to be dancing a little bit slow. But you can see you can almost start and stop a video using this technique. And I knew Diego's question for me was going to be, can I randomize this? So I threw in a little function here that you can pass in dash dash random. And what that will do is that will give you a random frame every time. So let's run this one and take a look at this. And so this one, it still maintains the right rhythm, but it just pulls a random frame instead of pulling in sequence order. So, again, you can begin to play with like how this would work. This might be a good thing, again, if you're maybe playing with gradients. If you have a big gradient image, this randomization would also give you like fun little like sparks into like, where things change up. This actually would be a lot of fun for the pattern video I was showing because you might want to, if you have a lot of really large patterns, you'll get sort of a similar color. Maybe you want to like introduce some sort of randomness into that, so there's a little spike of different colors as you go through it.
But
Yeah, go for it.
What does it random? The rhythm or the playlist?
It actually no, it actually randomizes the order in which it pulls the files. So remember that we're operating over a number of a sequence of images. So by default, it wants to go 1, 2, 3, 4. It wants to go in order, right? So if we remember this video, this first one, or the dancing guy, you'll see that each frame is actually in order, right? So when it's sequenced 24 frames per second, he's almost moving at the right speed. So random actually changes out the order in which these get pulled. But Laura's also asking, could we randomize the rhythm? We certainly could. One thing we could do here, which I have not built into this, but would be fairly easy to do, would be to say, pull randomly one of these, right? So take whatever order we're operating on, and let's grab a half hold, or randomly let's grab a hold 3. We could probably even weight these. So like say we want to weight toward, I want to do more, 1 frame per second, and just have a couple random places where it stops. We could probably do that. So I'm gonna, just like I did last time, I'm gonna add a little to-do list here of things for me to add. I think we could very easily do a random rhythm. That would be kind of fun to play with.
And there could be a way to from a song, an original song, or no, someone's song, get the playlist of that song and make this function with that song?
Yeah, so right now there isn't, but I was actually thinking about that. I was like, what you really need here is I think what Sean linked to, which is like how to convert BPM to frame rate. So if you knew the BPM of a song, we could very easily, and if you knew it was like four beats, it was a 4/4 track, we could probably just feed in 4/4, a BPM, and then we could actually have it change on a rhythm. And that would maybe what we would do then is we would predefine what these are, right? So we'd actually say like instead of 72, it needs to be, I don't know, at 120 frames per second. For a 3-beat hold would be a different value. So I think we could automate that really quickly. I could probably do that between now and next week. That was something that was sort of on my list, is BPM to frame rate conversion.
But that, is there a tool that, because that would give a constant result, but sometimes a song is, for example, is going like this, you hear like this, and the guitar player does some funky thing and goes tick, 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 and that could be faster, and then he stops and the bass is walking, so it's another rhythm, and
yeah, we'll look at
a drum solo is another rhythm.
We'll look at some of that next week. This is not a audio analysis class, so I couldn't do that if I tried. But I think there are definitely tools that could begin to get us there. What we'll look at next week, or one of the things I was going to maybe record a demo for, even if we don't get there, is I think Naoko and Steve were taking took my advanced Stallion class. We looked at how to connect the StyleGAN model to an audio sequence. I was gonna look at a different tool, so I wasn't gonna look at the I wasn't gonna look at Hans's tool, but there's another one that also allows you to do sort of a similar thing. And what it does do some audio analysis. So it's kind of up to us next week. Where I'm flexible. We can look at any number of things. If you'll want to do like an audio analysis tool, we can look at Librosa, which does give you some of that. Or we could just play with like, let's feed a video into a StyleGAN model and see what we get out of it. So yeah, I'm down to like talk about whatever people are interested in. There are other tools like that will do BPM matching, those sort of things. Tracking a BPM is fairly easy. I think like that's like a pretty common. There's probably some uploader that'll give you the BPM if you upload a file. Doing more of the analysis of like, is this a drum section? Is it a bass section? Is a little bit trickier. That's where it might be more Librosa stuff. But yeah, I mean, this is sort of an open area where like we can do whatever we want. You know, if like 20% of the class wants to do the StyleGAN stuff, I'll record a demo on how to use it, and I'll share it in over Slack. And if 80% of us want to look at Librosa, we can do that. It's sort of up to us. Like I would say, like I'm down to do whatever. I've got a little bit of time this week to sort of sort through some things. So if there's anything in particular people are interested in, I'm happy to work on whatever.
I'm just wondering.
Yeah. Come on, if you explain a little bit more what you're thinking about there, I could maybe say yes or no. The trick of with all this stuff is that it's very easy to do. Or I shouldn't say it's very easy. It's possible to do just about anything we're asking, and it's more just about like what's the right nomenclature to set it up. So it's like, would you want to do something like when you get to frame 35, hold that for a certain period of time. The trickier place it gets to is like if you see a person in a red hat, pause. Like that's where you need to then look at like more of some maybe Wekinator or some other tool to sort of begin to provide those sort of techniques to tell us when something is in the image. Yeah, the truth is the world is our oyster here. We could do a lot with this tool. We can move on to other things. So it's kind of like whatever anyone is interested in. Or I'd even say like if there's something that you thought was really fascinating about one of the videos we watched last week, or some of the stuff we talked about, this week, or some of the things we talked about, I'm happy to sort of cover whatever we're interested in. Cool. So I heard so what I'll do is maybe tonight, maybe I'll just post a poll in Slack and just sort of see if people are interested in sort of the audio reactive StyleGAN, if we're interested in some audio analysis, those sort of things. And I will let the group decide democratically what we cover, and anything that I don't cover but gets a vote, or like anything we don't do but gets a vote, I will record a video in the near future on, like before this class is over. So you'll have something to work with if that's something that interests you. Any other shout outs for something that people want to work on or play with? I know another thing we talked about briefly was maybe taking the open pose detection and in P5 being able to generate sounds from that. Like, are there other things people are interested in? Okay, I'll take silence as a no. So what I'll do tonight is I'll just non-pose object detection. Okay. I'll see. Okay, we could probably do that with like something like Coco. Yeah, that's also a good thing that I think Wekinator does, which is like you can hold up your cell phone and it'll detect that. You can hold up like a water bottle and it'll detect that. You can sort of like change out the sounds with different things. So we could also look at that. All right, well, I'll post some options. If I don't cover your option and you want me to, just DM me, and even if we don't get to it in class, I'll make sure to try to record a demo on how to do it. So everyone has this notebook, so you should be able to at least make a little rhythmic thing. Feel free to play with this, and as I said, if there are other features you want added here, just DM me. And again, maybe we won't get to it this week, but I'll try to get to it before class is over, so you've got access to it. Sound good? All right.
And we
Yeah, go ahead.
the spec again that you mentioned earlier in the beginning?
Yeah.
Will you be running through that at all?
I'll record a video on how to do that, and then I'll just upload it to YouTube and let everyone come and watch it from there. Because I don't love the results most of the time, I won't really go through a whole demo in class, but I'm happy to upload a little demo for anyone that wants to try it. It is kind of, it's not the best. It creates lots of noise, like you heard, but it's fun to play with. All right, cool. Well, I'll drop a poll in either tonight or first thing tomorrow, and just maybe try to vote on it before the weekend is out, just so I have time to build up whatever tutorial we want to look at. And yeah, I will see. Oh, one other thing is, I'm fairly certain I will not be able to do co-working on Sunday at the time it's specified, so I'll probably move it again. So just keep an eye out for that if you're planning on attending co-working on Sunday. Tuesday should be fine. I don't think I have anything going on that time. And so again, you're always welcome to come to co-working with whatever topic you have. If you want to look at stuff from 2 weeks ago and just have an idea about something going a little bit further on something or have questions, we can look at that. We can look at stuff that we covered today, future stuff, those sort of things. You're welcome to show up with any questions whatsoever, and we'll cover it in the order in which people arrive, which usually is pretty low, so you almost always get your question, attention to your question. So yeah, so I will see many of you, I hope, in co-working, and if not, I'll see everyone Thursday. Right?
Thank
Bye, everybody.
you.
Yep.
Thank
Eric.
you.
Good to see
Thanks,
you all.
Eric. Soon.
Bye.
Thanks.
Thank you, Eric.